Yes, next we discuss lattice enthalpy. Okay, lattice enthalpy. What is lattice enthalpy? The enthalpy change occurs when one mole of a solid ionic compound dissociate into its gaseous ions. Okay, once again, the enthalpy change occurs when one mole of solid ionic compound dissociate into its ion in the gaseous state, or we have to say that gaseous ions. Okay, for example, again we consider sodium chloride. NaCl solid is dissociate into Na plus gas plus Cl minus gas. Okay, the lattice enthalpy delta lattice H naught is equal to plus 788 kilojoule per mole. 788 kilojoule per mole. Okay, what is lattice enthalpy? The enthalpy change occurs. Okay, the enthalpy change which occurs when one mole of a solid ionic compound. The compound must be solid and ionic in nature. Okay, one mole of solid ionic compound get dissociate into its ion in the gaseous state. That's very important. Or we have to say that get dissociate into gaseous ion. Since it is difficult to determine the lattice enthalpy directly by experiments or direct experiments, we use another method. The method is known as Born-Haber cycle. Okay, we cannot determine the lattice enthalpy directly by experiment. Okay, it is difficult. So here we use another method, Born-Haber cycle. It is also according to the Hess law. What is Hess law? The enthalpy change is same whether the reaction takes place in a single steps or several steps. Okay, single step or several steps. Okay, let's discuss Born-Haber cycle. Okay, Born-Haber cycle. For that we consider the reaction. Once again I write Born-Haber cycle. Haber cycle. Here we take NaCl as an example. NaCl solid is converted into formation of NaCl. Na solid plus half Cl2 gas, that gives NaCl solid. The reverse process is a splitting of the compound. Okay, so here Na solid plus half Cl2 gives NaCl solid. To understand the Born-Haber cycle, we consider the formation of NaCl. Okay, and now we think this reaction takes place in different steps. First step is Na solid is converted into Na gas. What it is? Solid is directly converted into gas. What the process? Sublimation. We already discussed the sublimation enthalpy. Delta sub enthalpy. Okay, delta sublimation enthalpy. And next this sodium gas is converted into Na plus gas. What it is? We discussed in the third unit, ionization enthalpy. Delta IH naught. Ionization enthalpy. Okay. So Na plus gas we obtained. In the next steps, the Cl2 gas, chlorine molecule is converted into Cl gas. What it is? In Cl2 means Cl bond to Cl. The Cl-Cl bond breaks. That's why it is bond dissociation enthalpy. That is bond enthalpy. And you look at this. Half molecule is. So half bond dissociation enthalpy. Not 1 mole. Half mole. So that's why it is half the bond dissociation enthalpy. Next is Cl is converted into Cl minus. Okay, the Cl is converted into Cl minus. What it is? Electron gain. Chlorine electron gains. Here sodium loses 1 electron. That electron is gained by chlorine gas. Okay, so Cl minus gas. Cl minus gas. In the next step, Na plus gas and Cl minus gas combines. Na plus gas and Cl minus gas combines to form NaCl solid. This is lattice enthalpy. Lattice enthalpy. You suppose it is lattice enthalpy. Actually, it is negative lattice enthalpy. Okay, so NaCl solid is converted into Na plus Cl minus. That is lattice enthalpy plus sign. When the reaction takes place in the reverse, it also lattice enthalpy, but sign changes. Okay, when the reaction is reversed, you know that the sign of the enthalpy change must be changed. Okay, value is, the magnitude is same. Okay, the magnitude is same and the sign is different. Okay, so this is Born-Haber cycle. So in order to understand the Born-Haber cycle, we consider the formation of NaCl from metallic sodium and a chlorine molecule. Okay, metallic sodium and a chlorine molecule. The reaction takes place in a single step. The reaction takes place in a single step. Also, we consider NaCl solid is formed through different steps. Sodium is converted into sodium gas, sublimation enthalpy. Sodium is converted into sodium plus gas, ionization enthalpy. Half mole of chlorine is converted into chlorine gas, half the bond dissociation enthalpy or half bond enthalpy. So next is Cl gas is converted to Cl minus gas. It is electron gain enthalpy. Okay, electron gain enthalpy and ionization enthalpy we discussed in the 3rd unit. Then now Na plus gas and Cl minus gas combines to form NaCl solid. That is lattice enthalpy. Okay, minus lattice enthalpy. You just keep it in your mind. Then these steps we explain one by one. Okay, and we have to determine the lattice enthalpy. Okay, I just erase this cycle to do the other problem section. In NCERT book, the cycle is given in another pattern. That also correct. Okay, but I think it is easy to understand. Okay, this pattern is easy to understand the Born-Haber cycle. The NCERT book also given some other diagram. That's also correct. Okay, you go through it and this is easy for understanding. Okay, then we consider the reactions one by one. You keep this cycle in your mind and we consider the reactions one by one. What is the first step? First step is sublimation of sodium. Okay, sublimation of sodium. Let's write Na solid gives Na gas. The sublimation enthalpy is equal to 108.4 kilojoule. Now we move to the problem section in Born-Haber cycle. And the second step is ionization of sodium. Ionization of sodium. That is Na gas. Okay, sublimated the sodium atom or sodium, simply sodium. Sodium gas is ionizes into Na plus gas plus 1 electron. The ionization enthalpy for this is plus 496 kilojoule per mole. The ionization enthalpy of sodium is 496 kilojoule per mole. And the third step. The third step is dissociation of chlorine. Dissociation of chlorine molecule. Okay, here half Cl2 gives Cl gas. For one Cl, okay, Cl2, the bond enthalpy is equal to 242 kilojoule per mole. We discussed in the previous section. Okay, bond enthalpy section. You just refer the atomization enthalpy and the bond enthalpy. Cl to the bond enthalpy. The bond enthalpy is equal to 242 kilojoule. So what about half moles? When you divide an thermochemical equation by a factor, you divide the enthalpy change also. So here the enthalpy change, half the bond dissociation enthalpy is equal to 121. 242 divided by 2, 121 kilojoule per mole. A simple concept. And the fourth step is electron gain of chlorine. Electron gaining. Electron gained by Cl atom. Electron is gained by Cl atom. Okay. Cl gas plus 1 electron gives Cl gas plus 1 electron gives Cl minus gas. Cl minus gas. It is known as electron gain enthalpy. And electron gain enthalpy is equal to, you studied in the third unit, minus 348.6 kilojoule. Roughly you can take 349 kilojoule per mole. Are you clear? And finally, the fifth step, lattice enthalpy we have to calculate. Finally, this Na plus and Cl minus, Na plus gas plus Cl minus gas gives NaCl solid. That is lattice enthalpy. And which is, we have to determine. We have to determine the lattice enthalpy. Okay? Then for that, we consider the Born-Haber cycle and Hess law of constant heat summation. Okay, so these are the different steps, very important steps. You also keep it in your mind, the Born-Haber cycle. Then these are the 5 steps. Then according to Hess law, we can write that. Okay, I just erase the 2 or 3 steps to complete the problem. First step is sublimation of sodium. Second step is ionization of sodium. Third is dissociation. Okay, then according to Hess law, delta formation enthalpy of NaCl. Delta formation enthalpy of NaCl is equal to, first of all I write that Na solid plus half Cl2. Okay, Na solid plus half Cl2 gas gives NaCl solid. The formation enthalpy is equal to minus 411.2 kilojoule per mole. the reaction takes place in a single step. Okay, then according to Hess law, the formation enthalpy is equal to first step delta sublimation enthalpy, second step delta ionization enthalpy, third step delta half the bond dissociation enthalpy plus fourth step electron gain enthalpy, all in the standard form. Next, the last one is lattice enthalpy, delta lattice enthalpy. Okay, you should keep the Born-Haber cycle in your mind. Okay, the process takes place in a single step. In Born-Haber cycle, Na solid plus Cl minus gives NaCl solid. That is formation enthalpy. And we discuss the different steps. Then we have to determine the lattice enthalpy. Okay, this enthalpy we have to determine. So delta lattice is equal to, delta lattice enthalpy is equal to this thing. Okay, we move into the left side. Delta formation enthalpy minus of delta sublimation enthalpy plus delta ionization enthalpy plus half the bond dissociation enthalpy plus electron gain enthalpy. Let's substitute the values of these enthalpies. Okay, let's substitute the values of these enthalpy changes. Formation enthalpy minus 411.2 kilojoule, minus 411.2 kilojoule, minus of sublimation enthalpy is minus, here it is plus 108.4 plus ionization enthalpy 496, half the bond enthalpy 121, and the electron gain enthalpy is minus 348.6. all are in kilojoule per mole. Okay, all the values are in kilojoule per mole. So you take it in the common factor. And the final value is minus 788 kilojoule per mole. Okay, understand that this is the enthalpy change. Na plus gas plus Cl minus gas gives NaCl solid. According to the definition of lattice enthalpy. Okay, according to the definition of lattice enthalpy, what is lattice enthalpy? An ionic solid is dissociate into its gaseous ion. Okay, that is lattice enthalpy. You just reverse the equation. Na plus gas plus Cl minus gas combines to form NaCl. The lattice enthalpy minus 788 kilojoule. When the reaction is reversed, the enthalpy change is reversed. What about this? It is plus 88 kilojoule per mole. Na plus and Cl minus combines to form NaCl. It is from the Born-Haber cycle. Okay, it is from Born-Haber cycle. Na plus gas plus Cl minus gas, NaCl solid, lattice enthalpy. Or you can think that it is negative lattice enthalpy is 788 kilojoule. Okay, lattice enthalpy is minus 788 kilojoule. According to the definition, the process is solid substance is converted into gaseous ion. Just reversing the above equation, and also you change the sign of the enthalpy change. Okay, so this is the problem based in the Born-Haber cycle. It is very important, usually asking in the board exam as well as in competitive exam. So practice this. Okay, And one more important point, according to Hess law, enthalpy of solution is equal to lattice enthalpy plus hydration enthalpy. Okay, we have to wind up the section. Before that, according to Hess law, delta solution enthalpy is equal to delta lattice enthalpy plus delta hydration enthalpy. Now we consider the sodium chloride. Lattice enthalpy is plus 788 kilojoule per mole. And the hydration enthalpy of sodium chloride is minus. Okay, hydration enthalpy plus minus 784 kilojoule per mole. That is plus 4 kilojoule per mole. The dissolution of NaCl in water required a small amount of heat energy. Okay, the dissolution of NaCl in water plus 4 is a small value, plus 4 kilojoule per mole. Okay, so that's why we can say that dissolution of NaCl required a small amount of heat energy. Okay, so this is about the lattice enthalpy and Born-Haber cycle. And next section, okay, in the next section we have to discuss spontaneity, another important concept, entropy. Okay, entropy we will discuss in the next section. Thank you.